mainly the optical remote sensing data. It covers visual and near infrared range, or we can say from 400 to 750, that is your visual wavelength region, and near infrared is 1 millimeter. And after that, it is microwave satellites. These satellites are entirely different because optical remote sensing satellite based on the reflectance, and microwave remote sensing satellite depends on the back scattering. So back scattering of electromagnetic radiation. So two groups are satellites are there, and third one, the sensors also are there in thermal remote sensing, which used to sense the temperature of the Earth's surface. So if you see the process total, how it is being taken here. So the radiation is coming, optical remote sensing. Sun is the source of radiation. The radiations come to the surface, Earth object, it falls on the vegetation, crop, or barren area or open area. Radiation is reflected and recorded in the remote sensing satellite, and from there the reflected radiation is sent to the data receiving station. In India, we have only one data receiving station located in Hyderabad, that is Sadnagar. All the data antenna is there, which receive the satellite data from this antenna. Even the foreign satellite data also received at this data receiving station, and then this data is sent to the remote sensing data analysis. There we capture the scene by scene, and it is used for the processing for preparing the various thematic maps. This is a simple about the remote sensing. And in the remote sensing, from very beginning, we are preparing the false color composite. And how you have been seeing, suppose here 1 to 7 bands, but we cannot see at one time all 7 bands together. Our eyes can see only three primary color. We know that is the blue, green, and red. 3 primary colors are there, and other colors are combination of that one. So what we did in that one, green color, the radiation, reflected radiation recorded in green band is projected as a blue, and the reflected radiation recorded in red wavelength region is projected as green, and infrared radiation reflected radiation in infrared wavelength region, because these are the camera, you can say these 7 cameras are there. So this camera record infrared reflected radiation, which we project red color, because infrared our eyes cannot see, but there is a lot of information present into the infrared and red radiation. So in standard internationally, it was accepted that green as a blue, red as a green, and infrared as red, and then it combinations what you form the satellite image, we call it is standard false color composite. And this standard false color composite we can use for visual interpretation. So what then you will like to know, which are the remote sensing satellite data today is available. So today we are having Cartosat 2, and this satellite data is giving 56 meter spatial resolution to 5.8 meter spatial resolution. You can say that is a list 3 camera, list 4 camera, even panchromatic camera, Cartosat 3, recently launched in 2019, it is giving 45 centimeter spatial resolution. Means it is a very high resolution camera, and in color mode, multispectral, MX means multispectral means color mode, it is giving nearly 1 meter of spatial resolution. So you can see that is our camera resolution has increased many folds. When we launched first our satellite in 1988, at that time our camera resolution was 72 meter, and we have reached to a 1 meter spatial resolution in color mode. So tremendous resolution, tremendously it has increased, and we are observing this satellite data of the same picture of the same place every 18 to 22 days interval. But people demand is there that we want to see every 4 days or weekly basis or fortnightly. So this satellite data, this new satellites is in plan to launch resource set 3 and 3A, where you will weekly and fortnightly will get. But another group of scientists, users, they want that every day I want to see the remote sensing satellite data. You know that for that one, geostationary satellite data, as it gives the picture of Earth every day, but they are putting the camera in such powerful that every day you will get the satellite data. Of course, little bit coarse resolution of 42 meter. So it is a great means remote sensing satellite data are going to meet all the requirement from regional, continental, or local scale village level. So today we can generate the information from village level, district level, state level, regional level, or continental level. And what these remote sensing satellite data, Sentinel and Landsats are the from the Landsat from USA and Sentinel from Europe. It is available, and also some hyperspectral remote sensing satellite data where you are getting more than hundreds spectral bands. These are having up to 7, 8, or 4 spectral bands, but hyperspectral remote sensing, they are going to provide you the this satellite data is providing more than 100 spectral band. So you can say you can make a dissection of your Earth's surface and you can collect more and more informations what you do desire. So the future of the remote sensing are increasing in a quantum way. Another that you may also be aware that for processing of the remote sensing data, you need image analysis software. And when you prepare the map, then you need a GIS system, Geographic Information System. Now, it was started from DOS version to Windows version, and now it is available on the web-based or online GIS softwares are also available. And among them, various these softwares listed here, which you can download freely from your, even from your websites freely. And among them, QGIS, Quantum GIS, is largely being used by the users throughout the world, and many of you may be also using that one. So
the recording has stopped.
Then QGIS and GRASS softwares, these are very popularly used by the users who cannot afford the cost of the various commercial softwares. Another is that is your introducing with global navigational satellite system, because what you are getting the accurate position of any object on the Earth's surface, then you are using GPS. Actually, GPS is a name, the constellation of satellites of USA, which maintain 24 satellites. Glasnost is the your Russian satellites. They are Russian system that they are maintaining 30 satellites for recording the GPS location. And Galileo, Compass is from the China, and India also has launched its own constellation, we knowing as a Indian Regional Navigational Satellite System. So, like that's when from Earth, every country or developed country, they are seeing the Earth and finding the accurate GPS position. Why India has also maintaining their own navigational satellite system, because it was very much.
This meeting is being recorded.
It is very much required because during wartime, maybe other country, USA and Russian, may distort your signals, so your location will be very much compromised. So all the instruments, the defense instruments will not work. Therefore, India now maintaining 7 satellite system, 7 satellites for navigation system, and they are giving better than 10 meter accuracy, or even 1 to 5 meter accuracy in the defense purposes. So with this basic backgrounds of remote sensing and GIS, Now I move that is you are aware that is remote sensing and GIS are being used for various in agriculture sector for study of crops, for study of land degradation, for study of soil mapping or watershed assessment, soil erosion, various applications. I can say that today various applications are being addressed with remote sensing data. And if I show you one image of satellite remote sensing data, this is taken a false color composite. You can, by visual methods, you can analyze that one. That even that this is the Muzaffarnagar alluvial plain area in Uttar Pradesh, and you can see that is that this sugarcane plant, which is freshly planted, it appears light red, smooth. But when you go sugarcane ratoon, means 1 year, more than 1 year ratoon crops means first harvest, after first harvesting, second harvesting done, then growth is more. So in that case, ratoon is appearing this color, dark reddish brown. And fallow land is like this one. And popular plantation, which appears on the ground, this one, you can see they are appearing on the satellite data like this one. This is IRS list for 5.8 meter spatial resolution. You can say that in the field level crop type map you can generate by visual analysis method, and 5.8 meter satellite data you can freely download from the NRC websites. So now government has made it free. Means a spatial resolution less than 5 meter is only charged. So one thing is that we can use the remote sensing data, and ISRO has used the remote sensing data for land for mapping of degraded lands, and it has been found that ICR and the National Bureau of Soil Survey, Land Use Planning, and ISRO together they did this job, and they find that 1/3 of our country is degraded, and you can see 120 million hectare, and our total geographical area of our country is 327.8 million hectare. So future agriculture land is highly degraded, and forest land also 40% land is degraded. And you can say the major degradation is occurring because of erosion, or 80% is because of erosion, and out of that 70% is because of total degradation. 70% area is affected by your water erosion, and then your chemical degradation, which we calling at developing of salt affected